New Syllabus Mathematics Book 2 Updated 7th edition Chapter number 1 Primes, Highest Common Factors and Lowest Common Multiples. Exercise 1b, question number 7. Anusha needs to pack 171 pens, 63 pencils and 27 erasers into identical gift bags so that each item is equally distributed among the gift bags. Find the largest number of gift bags that can be packed, and then in the second part, the number of each item in a gift bag. We have 171 pens, 63 pencils, and 27 erasers. The question requires finding the total number of bags in which all three items can be packed equally. The first part of the question is to find the largest number of gift bags. This means determining the total number of bags in which all three items can be packed without any items remaining. Since the number of pens, pencils, and erasers will be the same in all the bags, so this problem can be solved by finding the highest common factor, HCF, of these three numbers. For example, if one bag contains 7 pencils, 6 erasers, and 13 pens, then this number will remain the same for each bag. As we know, the HCF is the product of the only common factors, so the number of pencils, pens, and erasers is also the same or common in each bag. Therefore, I'll be finding the highest common factor, HCF, of these three numbers. So factorizing 171 gives us 3 times 3 times 19. Factorizing 63 results in 3 times 3 times 7. And factorizing 27 gives us 3 times 3 times 3. The HCF is the product of common factors, which I have circled in red. And their product is 3 times 3 is equal to 9. Therefore, the largest number of gift bags that can be packed is 9. The second part of the question is to find the number of each item in a gift bag. Since we have calculated the total number of gift bags, which is 9, so let's determine the number of items in each bag. The number of pens in a gift bag can be calculated by dividing 171 by 9, which equals 19. The number of pencils can be calculated by dividing 63 by 9, which equals 7. The number of erasers can be calculated by dividing 27 by 9, which equals 3. Therefore, in each bag, there are 19 pens, 7 pencils, and 3 erasers, and the total number of bags is 9. Question number 8. Two race cars, car X and car Y, are at the starting point of a 2-kilometer track at the same time. Car X and car Y make one lap every 60 seconds and every 80 seconds respectively. How long in seconds will it take for both cars to be back at the starting point at the same time? And how long in minutes will it take for the faster car to be 5 laps ahead of the slower car? This question is the real-life application of highest common factor, HCF, and lowest common multiple, LCM. The problem is whether we should find the LCM of the given numbers 60 and 80 or the HCF of the given numbers 60 and 80. To answer the question, let's consider this example. In this scenario, the red circles represent a 2-kilometer track. Car X covers the 2-kilometer track in 60 seconds, while car Y covers the same track in 80 seconds. The speed of car X is faster than that of car Y, as shown in the figure. It is evident from the figure that car X will complete 4 laps in 240 seconds, while car Y will complete 3 laps in the same 240 seconds. However, both cars will be back at the starting point at the same time. The difference in the number of laps is due to the faster speed of car X, but they both return to the starting point in 240 seconds. Now, 60 120, 180, and 240 are the multiples of 60, while 80, 160, 240, and 320 are the multiples of 80. Among these multiples, 240 is called the least common multiple of 60 and 80, which is denoted as LCM. On the other hand, if you find the HCF of 60 and 80, their HCF is 20. This implies that both cars would return to the starting point in 20 seconds, which is not possible since they take 60 and 80 seconds to complete one lap. Therefore, the LCM is the solution to the question. So factorizing 60 gives us 2 times 2 times 3 times 5, while factorizing 80 results in 2 times 2 times 2 times 2 times 5. The LCM is the product of common and uncommon prime factors. First, I will write the common factors and then uncommon factors. Here common factors are circled in red and the rest are uncommon factors. And their product is 240. Therefore, it will take 240 seconds for both cars to back at the starting point at the same time. Now, second part of the question. How long in minutes will it take for the faster car to be 5 laps ahead of the slower car? Again, let's look at this figure. The faster car, X, completes 4 laps in 240 seconds, while the slower car, Y, completes 3 laps in 240 seconds. This means that the faster car is 1 lap ahead of the slower car in 240 seconds. To determine how long it will take for the faster car to be 5 laps ahead of the slower car, I'll multiply 240 by 5. That gives us 1200 seconds. To convert 1200 seconds into minutes, I will divide 1200 by 60, which gives us 20 minutes. Therefore, it will take 20 minutes for the faster car to be 5 laps ahead of the slower car.